Okay, so let's begin. So today we are going to I can't speak. So today we're going to define a recursive method, which is Fibonacci, and we're going to have a look at that. So let's begin. So let's begin by making a new project, and we're going to call that project Fibonacci. Fibonacci. And we'll just finish there. Now this is my file, and I'm just going to paste the method which I've defined earlier here. Now this is my Fibonacci method. Let's just have a brief look at it. So in our header we have static that allows us to access it in this file. We are going to return an int as a result of Fibonacci. And here we have the method header. Now some of us are probably thinking, what is Fibonacci? So Fibonacci is a sequence of numbers that essentially returns from 0 and 1 the value of the previous two numbers. So 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 5 is 13, and the story goes on. Now, there are two types of Fibonacci methods we can write recursively. We can write the sequence as numbers, as you can see above here, or we can write what value is returned, e.g. the nth position. So in the nth position of Fibonacci, what value is returned. Now, the first method is a recursive method, but we're going to look at the nth value. So if we're going to call this method, we would need to provide a system out print like so. We would type the method name inside. We require an int for this argument, so let's say we want to look at the 6th value within Fibonacci. So then we run the code like so, and it should tell us the 6th value, which is 8. So if we count here from 8, 1, 2, 3, 4, 5, 6. Now you're probably thinking, I've counted from 6 backwards, yes, and I didn't get to 0. I'll explain why, because we begin with our index position of 0. So 0, 1, 2, 3, 4, 5, 6. So therefore 8 is our 6th value along our Fibonacci chain. Okay, so now let's look at the method itself. So if n is the same as 1 or n is the same as 2, essentially return 1. Else return Fibonacci n minus 1 plus n minus 2. Now we can have a quick look at how that looks. Let's maybe go for a position down, or let's go for the 4th value along, which should give us 3. So let's just change that to number 4, and we can explain how that works. So that gives us 3 perfect. So if we can just consider it like this. So if n is the same as 1, currently it's 4. Is 4 the same as 1? No. Is 4 the same as 2? No. So we don't return 1. So then we go to Fibonacci. So let's just look at my notation. I say f4, and now the f represents our function Fibonacci, and now that's going to be equal to f3 plus f2. Okay, now on our next line, this is going to divide into 2 subsets. F3, okay, which is going to now equal f2. Okay, and that is going to be added to f1, my brackets, 1, and then we have to consider the next one, which is f2. So we say plus f open bracket 2 close bracket plus f open bracket 1. Now we know that the base case is 1 or 2, so we can kind of stop here. In fact, we could have stopped a lot earlier, but I'll just explain how this works. So if we consider F4 is basically equal to F3 plus F2, and F3 plus F2 is equal to F2 plus F1 plus F2 plus F1. Now let's explain. So with F4 you get F3 and F2. With F3 you get F2, F1. Okay, and with F2 here you return 1, so you don't actually get that even. Okay. Now, if we look at this, we know that 2 returns 1, so we can say R1 at this point. This 2 returns 1, and this F1 returns 1. Now, if we add each of our return 1s up, we have 1, 2, and 3. And that is our value here, 3. So that's how it works. Okay, I'll repeat that one more time. So we began with F4. Now F4 divides into 2 sections, which is F3 and F2. Okay, now F3 and F2. F3 divides into 2 sections, which is F2 and F1. F2 doesn't divide into any sections because it hits the base case, which is returning 1. So we return 1 at this point. And this F2 here also returns 1, and this F1 also returns 1. Okay, any questions? Okay, let's try another number. So let's imagine that we had F6, okay, as our amount. Okay, we know that F6 was equal to 8 up here. Okay, and now I'm going to give you a quick bit of a shortcut for this, because we know that F4 is equal now to 3. So it returns 3 as a whole. Okay, because we saw that through this return 1, this return 1, and this return 1, which was 1 plus 1 plus 1, which is essentially 3. So we know that F4 returns 3. So essentially, we don't need to go all the way down. Okay, and I'll represent this in code in a moment also. But we could say F6 divides into, becomes F5. Okay, and F4 plus F4. Okay. Now we know F4 already returns 3, so rather than going down that road, I can just put a return 3 there automatically. F5 I'm not currently sure, so I'm going to introduce a new line. I'll introduce a new line here, and I'm going to say F5 divides into F4, and that becomes plus F3. So with a little practice, we recognize already this returns 3. Okay, and we know from our previous experience that F3 returns 2. Okay, so we've got our 3 from the 4 here, plus 3, which is 6, and then plus our 2, which gives us, and I'll just put that in an easier way for us to visualize, 3 plus 3 plus 2, and that gives us 8. And then, as you can see, our value here is 8. If we wanted to represent that in code, the best way to do this, to say processing time perhaps, would be to say if n is the same as, and let's begin with 3, for example. If n is the same as 3, then we return 2. So return 2. Okay. Else, and then we'll make this an else statement. Else if n is the same as 1 or n is the same as 2, return 1. So the benefit of this, let's say for example we had the value 6 inserted into our method. When it gets to 3, it will automatically return 2. You may say, okay, so what's the point of 1 or 2 here? Then let's say that we put the value in there, which is 2. Okay, so if we put 2 in here, obviously it's going to go past this value because n is not equal to 3, so it will go to this condition, which is n is equal to 2. Or equally, if we put 1 in here, it will go to this condition. The reason why we put the 3 at the top is because obviously there's no point going to the lower conditions first. It's better to go to the higher condition. If the higher condition is met, then we never need to go to the lower conditions. So equally, I could also make this into an else statement. And if you just consider that each time that the recursive method is run, it's branching, this will save quite a lot of processing time, probably milliseconds, but I mean all the same, it saves time. So if n is the same as 4, for example, then we know that it's going to return 3. Okay, so again, if the number here is 5, then it will run 5. It will go all the way to the bottom, minus our 1 and our 2, and then when it gets to 4 on this side, then it can be dealt with. When it gets to 3 on the reverse side, and then obviously these two conditions will never be met. But again, we have to account for the fact that we don't know what the person or the user is going to enter into the Fibonacci method. Okay, so that's Fibonacci, and that is how you find the nth value. Now, with regards to Fibonacci, the series, that's going to require a little bit more coding. Okay, so I'm just going to make a new file, so new project, and I'm going to call it F sequence. So F sequence, because we are going to print the sequence in this situation. Okay, now I'm just going to have a quick think about the methods. So let's firstly public static void print fib, because it's printing Fibonacci. Again, we're going to take an integer value. This time we're going to call it, let's call it count, why not? Okay, and I'm just going to move that down a touch. Now we're going to say I need to probably introduce some static variables at this point, because we're going to have our constants, which is 0 and 1, our starting point. So I'm going to say static int, and these are going to be accessible throughout the whole file, that's why I've made them static, equals n1 equals 0. I'll explain this in a moment. n2 equals 1, and n3 we don't actually need a value for that, we just need to declare it as an integer. Okay, so n1 is equal to 0, n2 is equal to 1, and n3, okay, let's just make it equal to 0 as well. I should be able to do that without n3. What have I done wrong? Oh, my comma's missing. Okay, so I don't actually need to equate that to a value, we'll just put it at. So these are our starting values, because obviously we begin at 0 and 1. Okay, then within my method I'm going to say if count, okay, is greater than 2. And the reason why I say if count is greater than 2, because we know that the first two values within Fibonacci are 0 and 1. So essentially, if it's not beyond 2, there's no point to running the method. So we can print out, for example, 0 immediately here, and then we can print out 1. Okay, and we can just probably put some spaces in there as well. So 0 space and then 1 space. So those are our initial values that we can print automatically. So if the count is above 2, in other words, if we want to have a sequence that's greater than these first two positions, then run the method. If not, then we've printed out as many values as we want. I guess that's why sometimes people start the sequence at 1, because then if there's going to be one value printed, then at least you can just say 1. But fast forward anyway. So if count is greater than 2, and then we're going to basically add our values up. N3 is going to be equal to N1 plus N2. So what that's doing is basically, if you remember, we started our values 0 and 1. So 0 plus 1 equals 1. So the third value along, okay, which is our third value along would be essentially 1. Or we would say, okay, that's fine. And we can say N1 is equal to 2, because now we're transferring the values. It's a bit like our swapping algorithm. So N1 equals 2, and then N2 equals N3. Okay, so here we give the value of N1, which would be 0 at the beginning, we give the value of N2, which is 1 at the beginning, to N1, and then the total amount is N3, we give that to N2, so we're passing the values up. Then we add a system out print statement, because this is a void method, and then essentially we put N3, which will be our subsequent value. So I don't need that space because I've got one here. And then I run my recursive method, print fib. Okay, and each time we're going to minus 1, so we can go down the chain. Okay, so let's say, for example, and my semicolon is missing just there. So let's say, for example, count, and this could be input by the user if we wished, is equal to 10, and count is an int. Or let's just do one of our, so 10 is fine. So count is equal to 10, or let's just use one of our existing numbers we've used. So if count is equal to 4, okay, and then we have our print fib method here. Okay, we can get rid of the lin here because we want that to link nicely. Okay, so print, I'm pressing every button today, but the ones I need. Print fib, and then we just put our count value in here. So now if I just run this, okay, so my fourth value along is number 2 in the sequence, so that's perfect. Now what do I want to do? I want that to sit together nicely. So system out print, you're going to print on a new line. No, we don't want you on a new line, so let's run you again. Okay, there you go. And what we'll just do, should we add a new line at the end of it? System out print. Okay, so let's run that again, and that looks beautiful. So if we say 10, okay, and we print 0, 1, 1, 2, 3, okay, excellent. Now, I probably don't want my system out print there, I can just have it here, that's fine. And let's run you again, and that is perfect. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that prints the first 10 in the sequence. Excellent. Okay, so I'll explain that briefly. We have our static values here. N1 is equal to 0, N2 is equal to 1. And as we kind of discussed earlier, here we're just transferring the values along. Okay, so we start off with N1 plus N2, so we're essentially saying 0 plus 1, and we give that to N3, and that becomes 1. Okay, and then we have, if we go back around on the next call, N1 plus N2, which is going to be 1 plus 1. Okay, then we give that value to N3, so N3 gives that value to N2, sorry, So n2 becomes equal to 2, and so on and so forth. So you can probably get the idea. Maybe I'll just go through a couple of spins in code. So our first four characters, or our first four numbers are 0, 1, 1, 2. I'll just run through that one. So if we say our count is 4 greater than 2? Yes, it is. Okay, so therefore we say n1 plus n2, which is going to be 0 plus 1. So 0 plus 1, okay, is equal to 1. So n3 becomes 1. And then here, I'll just do it right here. So then you give your value 1 to, that becomes n1's value. Okay, and here, n2's value becomes also equal to 1. Yeah, I'm just writing this in the reverse, but hey. And then so on and so forth. The only thing to recognize here is that our count was the value we passed through to our fib method, and 0 and 1 were the first items we printed out. And this was just so I had a nice display. Any questions? Leave your comments below, or don't hesitate to ask me. So this allows us to print the sequence, and the previous method we discussed, Fibonacci, allowed us to print the nth value. Okay, I hope that was helpful.